Welcome to our demonstration of the e-commerce multi-agent system, built as part of Assignment 2 for SE 4010 at the Sri Lanka Institute of Information Technology. This system was developed by a team of 4 students, Harshan, Yatawaka, Randunu, and Narathni. It runs entirely on a local machine using Ollama and Crew AI, with zero cloud API costs and full data privacy. The system automates the complete order processing lifecycle using 4 autonomous AI agents working as a team. We launched the system from the terminal using the main.py entry point. The customer query is, I want to buy 2 wireless headphones Pro. The local model being used is Qwen 3, running through Ollama. You can see the system initializing. The inventory database and order store are confirmed ready. The orchestrator starts and logs the customer query to the console. Crew AI then kicks off the sequential pipeline, and the first agent, the customer intent agent, begins its work. The customer intent agent was built by Harshan. Its role is to analyze the raw customer text and extract structured intent. The agent calls 2 tools in parallel. First, the parse customer query tool, which extracts the action, product name, quantity, confidence score, and inferred product category. Second, the analyze query sentiment tool, which checks whether the customer is urgent or expressing any negative emotion. Looking at the tool output, the action is buy, the product is wireless headphones Pro, the quantity is 2, and the confidence score is 1.0, which is perfect. Sentiment is neutral, and no urgency was detected. The agent synthesizes both tool results into a clean structured JSON report and passes it to the next agent. State is now handed off to the inventory agent. The inventory agent was built by Narathni. It receives the intent report and immediately calls the check inventory tool against the local SQLite database. The tool uses fuzzy token overlap matching to find the best product match. In this case, wireless headphones Pro matches perfectly, with a match score of 1.0. The result confirms SKU 001, product name wireless headphones Pro, current stock is 45 units, unit price is $89.99, and the verdict is available. There is no low stock warning since 45 units comfortably covers the requested quantity of 2. The agent returns a clear, structured inventory report and passes state to the order processing agent. The order processing agent was built by Randunu. It receives the inventory report and runs a 3-step validation process. First, it calls the validate product tool to confirm the SKU exists. Then it calls check inventory again to atomically verify stock is still available. Only if both checks pass does it proceed to create the order. In this demo run, the validate product tool returned a not found result, and the inventory check returned unavailable. This is because the agent's internal validate product tool queries a separate product validation layer, which highlights a real-world integration scenario where the SKU confirmation step catches discrepancies between systems. The agent responds correctly by writing a clear decline message, recommending the customer verify the SKU or contact support. This demonstrates the system's fail-safe behavior. It never creates a phantom order. The report agent was built by Yatawaka. It receives the full context of all 3 upstream agents, the intent analysis, the inventory check, and the order outcome, and synthesizes everything into an executive summary. The agent calls the generate report tool, which reads the order store, aggregate session data, and writes 2 output files, a plain text narrative report and a CSV export, both saved to the logs directory with a UTC timestamp. The final output presented to the user includes the executive summary, the total number of confirmed orders, total revenue for the session, and the file path of the saved report. This closes the complete pipeline, from raw customer text to a persisted, auditable session report. Throughout the entire run, every agent start, tool call, and state transition was recorded in real time to the agent traces log file. This is the LLMOps observability layer. Each record carries the agent name, the tool called, its arguments, the result, and a UTC timestamp. This gives full auditability of every decision the system made. This demonstration shows a fully functional multi-agent system running locally. No cloud, no paid ARPAs, no internet connection required. The 4 agents, customer intent, inventory, order processing, and report, collaborate as an autonomous team, each owning a distinct responsibility and communicating through structured state parsing. The system achieved 53 out of 53 parsing tests, including unit tests, edge case tests, property-based tests, and LLM as a judge assertions, 1 full test suite contributed by each student. Thank you for watching. The full source code is available in our GitHub repository.